Okay, now would be a good time to try an exercise. So give this exercise a try. I'll give you the answer here. So pause, copy, try, pause, copy, try, pause, copy, try. Moving on. Example. Now, here we have something similar to the first example, but a little extra problem here. But we just jump in, choose u to be x squared. You'll notice I'm choosing u to equal a polynomial a lot. I would say maybe 80% of the time that's going to happen. But I'll have more to say on these choices later. Okay, u is x squared, dv is the rest. Okay, differentiating gives me 2x over here, and integrating gives me just e dx over here. Plug it all in to my formula, uv minus v du. You'll notice that I've done some extra moving things around. Don't be afraid to pause the video and convince yourself, maybe on the side over here, with a few calculations, convince yourself that this is correct. Okay, that's always a good idea. So, oops, before I move on, let's talk. What do I have here? I notice here that, not as nice as my preceding examples, but certainly better than the original, right? What is happening? Well, this power of 2 went down by 1. So I say, well, let's do by parts again. So I will do by parts again. But I want to emphasize that when I went from here to here, I made progress. And that is what is motivating me to continue. So I'll do by parts on this new integral. Exact same thing I did in the first example, so I won't take too much time to explain it. You get the blah, 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 and the boo, boo, blah, and you plug it back in, and Bob's your uncle. Well, Bob is not quite your uncle. You need to be very careful. I did by parts my second time here, and the use of brackets is absolutely critical. Okay, you need to be very careful with that because this is almost always a minus right here. You see? So because I have a minus here, that means that the sign here is eventually going to change. So if I don't have brackets, I'm going to miss that. I'm going to miss a lot of things. So brackets, extra special here. Okay, but I am pleased because I made my x here, I made it go away. And I have a very, very simple integral there, which I perform and work it out. And I'm set. So look, this I ended up with a plus here. I ended up with a 2 here. Okay, it's because of the red brackets that happened. Okay, without the red brackets, you were quite wrong. Okay, this is a by parts in which I had to do the formula twice. There is something called the tabular method or table method. It allows you to do these types of problems quickly. So if you are interested, you could have a look at Google, try to figure out that method. I mean, it's helpful if you have to do by parts, I'd say more than twice, which happens here and there. But some students really like it. Okay, I've been making choices seemingly willy-nilly, but there must be some method to my madness. First, I'll give you some motivation, which I've kind of given already. When you pass from the original integral to this new integral, okay, you want to see some progress. Okay, you want to see things get better. If you see things getting better, then keep going. Otherwise, you need to rethink your choices here. Okay, that's the main thing. Okay, you want to make progress when you apply by parts. What else? Um, that's the main thing. Another thing is a acronym. I believe it's something like this. LIPET. Ooh, I'm not really up to speed on this one, but I'll at least mention it. You can Google it if you're interested. What does it tell you? It tells you how to choose U. So how do we use this? Well, if you have an integral, and it involves L equals logs, or ln of x. This acronym tells you that if a logarithm or a ln of x is present, then that should definitely be U. I stands for inverse trig. P stands for polynomial. E stands for like e to the x exponential, or 2 to the x. T stands for trig, just normal trig. So the acronym gives you a kind of order of operations. Okay, if your integral involves ln of x, then u should equal ln of x. Okay, if there's no log, then you start looking for inverse trig. If there's no inverse trig, then you start looking for polynomial. That's what we've been doing so far, is we've just done cases where u equals polynomial. Anyways, you may want to Google this acronym. And I think many students find it useful. But for me, the main thing I think about is A, focus on making progress when you get this new integral here, and focus on doing lots of homework. Unfortunately, you need to develop an intuition through some persistence.